A differential equation is simply an equation with differential coefficients. If you're solving a differential equation, you are eliminating those differential coefficients. In this video, I'm going to explain how you solve differential equations by separation of variables. There are different ways of solving different forms of differential equations, but I'm just going to concentrate only on those differential equations where you can separate the variables. What I mean by variables, I mean x and y, or if it's a t and an x involved in that equation, you can be able to separate the variables. Let us say we have a differential equation with x's and y's. When you're separating the variables, you're taking the x's to be together and the y's to be together. Then you integrate the x's in terms of x and you integrate the y's in terms of y. That's all you do. Now you're going to have two types of solutions. The first type of solution is called a general solution. A general solution includes what we call arbitrary constants. So after doing your solving, you are left with constants like a or b or c, and you don't know the values of those constants. That's what we call a general solution. Then sometimes you are given information that you can use to solve for the values of the arbitrary constants. That kind of solution is called a particular solution. I'm just going to highlight how you do this using two examples. The first example, I'm looking for a general solution, and in the second example, I will look for a particular solution so that you can understand both scenarios. Now, let us go to this example here. We are required to find the general solution given this example. Yes, it is a differential equation because we have dy here and dx. These are what we call differential coefficients. So it is a differential equation. Now, if we are to solve this, we are removing or we're eliminating these differential coefficients. And when I look at this question, I can separate the variables. I can separate the x's, I can separate the y's. That is the first step that I'm going to do, which is separating the variables. It's not a complicated affair. You just have to use your skills of algebra, how you do this separation. Now I'm going to take everything. I'm taking the dy's or the y's to the right hand side. I'm leaving the x's on the left hand side. That is what I'm going to do. So if I do that, I will have here cosine of x dx divided by cosine of x dx divided by sine x. This will be equals to 6y over 3y squared plus 2 dy. I have managed to separate the variables. So the variables with x and the dx are together, and then the variables with y and the dy are together. From here, I can now do my integration. So on the left hand side, I'm going to integrate here with respect to x, and on my right hand side, I'm also going to integrate with respect to x. All I do here depends on my knowledge of integration. Do I know how to integrate the expressions or the functions that I have on both sides? If I know how to integrate them, then half the battle is done. Now, if you look at what I have on the left hand side, cosine of x over the sine of x, that is like cot x. So it's like I'm integrating here cot x. So this is like integration of cot x dx being equals to the integration of 6y over 3y squared plus 2 dy. Now, if I go to my formula sheet, I'll find the integral of cot x. So I have here the integral of cot x. And if I look at this situation that I have on the right hand side, the numerator is the derivative of the denominator. So it's like I have something like f prime of y over f of y. And I know how to integrate this situation here. The answer is simply the ln of f of y. That's how I do it. Now, so from here, I just need to consult my formula sheet and then I get my answers. That will be the final step. All right, so let me check my formula sheet. The integral of cot x is ln sine x. That is the integral of cos x. It's ln sine x. So I write here ln sine x equals 2. If I integrate 6y over 3y squared plus 2, I get ln 3y squared plus 2 plus c, a constant. I don't have to know, or I don't need to know the value of the c, because this is a general solution. So this is what I call an arbitrary constant, because if they ask for a general solution, they don't want you to find the value of this c, and we don't actually have information to find c, so we can actually leave our answer in this format. This is how you solve this general this is how you get the general solution of this differential equation. We separated the variables and we come out with this. Now I want to do another example, and in the next example we are going to find a particular solution. So this is in the next example we're going to find a particular solution, which means in this example we are going to find the values of our constants. We have this information here is there for that. We're going to use this information to get the values of our constants. Now if you look at our question, the variables have already been separated, sort of. If you integrate, because we need to understand that integration is the reverse of differentiation. So if we have something that was differentiated, if we want to go backwards, we integrate. So now this is what we're going to do. If we integrate on the left hand side, if we integrate here, d squared y over dx squared, this is the same as integrating here 3x squared minus 2x with respect to x. These are already separated variables. There's nothing much you have to do. You just do direct integration from here. And if you integrate a second derivative, you get a first derivative. So what you get here is actually dy dx being equals to 3x squared. If you integrate 3x squared, you get x cubed. And if you integrate 2x minus 2x, you get minus x squared. And then you are adding a constant. Let us call it a. We add a constant, but we don't know this a, but we have information to know it. We are told that dy dx is equals to minus 1, x is equals to 1, and y equals to 1. So from there, we're going to use dy dx and our x, and we find what is our a. So now I'm going to put here dy dx is minus 1, which is equals to 1 cubed minus 1 squared plus a. From here we can say our a is equals to minus 1. So that is our a. We have our a now. Once we have our a, it means we can rewrite this as dy dx. So dy dx is equals to x cubed minus x squared plus a, which is minus 1. Now we do integration again, because as long as we still have differential coefficients, we haven't solved our differential equation. So let us do direct integration once more. If we integrate dy dx, so we are integrating dy dx, and this side we are integrating x cubed minus x squared minus 1. We're integrating in terms of x. If you integrate dy dx, you get y. So we have y here being equals to x to the power 4 over 4 minus x cubed over 3 minus x plus b, which is a constant. We don't know b, but because it's a particular solution, we must know b. What are we going to use? We're going to use the initial condition that we're given, that x equals to 1 and y equals to 1. So where there is x, I'm putting 1. Where there is y, I'm putting 1. So from here, we can say 1 is equals to 1 to the power 4 over 4 minus 1 to the power 3 over 3 minus 1 plus b. So from here, we can solve for our b. Just a matter of punching into your calculator. So this is a plus, this is a plus b. So we just, our b is actually 1 minus 1 over 4 minus 1 over 3. So minus 1 over 3. That is our b. It is 5 over 12. I get my b as 5 over 12. No, let's do it. So it's 1 minus, so it's 1 minus 1 quarter plus 1 over 3 plus 1 over 3 plus 1 is 25 over 12. So our b is 25 over 12. Let's go to that. So we found that our b is 25 over 12. Now we know that our y is equals to x to the power 4 over 4 minus x to the power 3 over 3 minus x plus a b. This means our final answer is y equals to x to the power 4 over 4 minus x cubed over 3 minus x plus 25 over 12. This should be the final answer. Have we solved our differential equation? Yes, we have solved our differential equation because we no longer have differential coefficients. Did we find a particular solution? Yes, we found a particular solution because we no longer have arbitrary constants. We actually found the values of these constants. This is how you solve differential equations when you can separate the variables. This is the method that you use. Thank you for watching the video. If you have any queries or any comments, write in the comment section below. Otherwise, give the video a thumbs up and subscribe to the channel.